All right, so the first thing we got to do is actually look up these masses, and I'll show you how to do that, right? So remember, it's lithium 7, tritium, a neutron, which we kind of know what that is, right? That's actually in your data table, not in the reference I'm going to give you, your data packet. And then beryllium 9, right? Okay. So let's just look those guys up. All right, so let's see. Lithium 7 is this guy, right? So I'm just going to type that into my calculator. 7.0160, whoops, 049. Is that right? No, 004. 04. 7.016004. Got it. All right. And then we also had tritium, right? So here's tritium. The T is tritium. You'll have to memorize that. All right. And that is 3.016049. I'm just typing these into my calculator because I can't. All right. And then the next thing is beryllium 9. I'll try to assiduously avoid using things that are not in your table here. So 9.012182 is 9.012182. All right, good enough. And then the crazy thing is that a neutron is not on this list. It really should be on the list, but it's not, because this is, I don't know, not that helpful, right? But I'll put it on the, it's in your data packet, and it's in, I think I put it on the assessment. Okay, so anyway, let's go back here. So this is 7,3 lithium plus 3,1 hydrogen, right? That's what a tritium is. And then it's 1, 0 neutron plus 9, 4 beryllium. Do our numbers add up? Yeah, they do. This is good. Hopefully it's a balanced equation. Otherwise, it'd be like, uh-oh, wah, wah, wah. All right. So let's see. This guy, this mass was 7.016004 plus 3.016049. And then this becomes 1.008665. And this is, I believe I put this on the assessment itself. Okay, it's also in your data packet. You can find it. They give it to you there. Plus, let's see, 9.012182. Okay. Now, here's the deal. If the right side loses mass, if this has less mass than this, you have to ask the question, where did the mass go? Where did that mass go? Well, it turned into energy. It gave off energy, right? Okay. If the right side gains mass, you have to say, well, where did that mass come from? And of course, it came from the energy of this bombarding particle. Okay. So it came from kinetic energy. So let's just look at the mass here. I'm going to add up the left side and the right side. So I'm going to go this guy plus this guy. And I get 10.032053. And then let's add up this right side here. The 9 plus 1.008665. And this is 10.020847. Now it's quite apparent that we've lost mass here, right? So this is going to give off energy, right? So this is plus energy to balance that equation, right? Okay. So now what I'm going to do is I'm going to just subtract this, right? So let's go this guy minus this guy. And I get that the mass went down by 0.011. This energy is 0.011206 U's worth of energy, right? That's what this is to balance this equation, right? And so the energy released is 0.0112006 U's times 931.5. Because that is, if we take 1 U and turn it into energy, this is how many MeV it is, right? That's the meaning of that. That's MeV per U, right? And I get 10.438. And we have 1, 2, 3, 4, 5 sig figs here, but only 4 there, so we have to round this to 10.44. There you go. The Q value. So just look up what these things are, right? The T is tritium, right, and is neutron. Look them up. don't mess up the numbers, right? And then it's what is the Q value is the amount of energy released. So positive Q is released. Negative Q is required. Right, so it's endoergic, right? If the Q value, if we gain mass, it's endoergic, right? If we lose mass going from left side to right side, it's exoergic, okay?